And welcome, viewers, to the Daily Space Weather. Congratulations on realizing that our channel exists. We're looking at the sun here in ionized helium. Some prominences here, both in the northwest as well as in the southeast. It looks like there's another sunspot rising. Generally pretty weak solar activity here. We've got some elevated geomagnetism. We'll get to it. Also a calibration maneuver going on where the SDO moves around to ensure that it's oriented directly at the center of the solar disk. This composite image includes ionized helium and two ionized iron states. Those are 211 and 171 angstroms. The ionized helium is 304 angstroms from the Solar Dynamics Observatory. And here's your intensity gram. Sunspot 2843 down here, looking like it's degraded over the past 24 hours. 2842's remained largely stable. And this one, we thought it would be named 2844 yesterday, but it looks like it has vanished. So you see some umbre right here. Those apparently were not there long enough to get a name, I think. Here's the diagram of the solar system. As we approach another full moon, let's advance it 1 week. There's where things will be on July 22nd. The 10.7 centimeter radial flux is at 72 solar flux units, having flatlined here, dropped back down to essentially solar minimum conditions. Surprised that that has not gone up yet. And here's a space weather enthusiast dashboard. No geomagnetic unrest or storms in the forecast. And the global earthquake drought continues here, folks. Only 1.7 magnitude earthquake here in the past 90 days. Let's check the list from USGS. If you're in an earthquake-prone zone, please have a plan for when buildings perhaps start to collapse or whatever. If you'll evacuate, know if a building facade may collapse. Have a bug-out bag. Be an asset, not a liability, in the event of a disaster. So, looks like one of the largest of the past 24 hours in terms of earthquakes was this 5.3 at Guam. Almost exactly 24 hours from when we made this video. There was also a 5.0 in China. Or if you prefer the alternate pronunciation, Ched. Ched. A couple of deep quakes, such as this 4.5 at Myanmar, this 4.3 at Chile, and this 4.4 at Kamchatka, the southern portion of the Kamchatka Peninsula there. Also a very deep quake near Fiji, a 5.1 at over 620 kilometers depth. Also a deep quake here in Afghanistan, a 4.1 magnitude at 189 kilometers depth. Also deep quakes at Timor-Leste and New Zealand, both in the mid-4 magnitude range. And also of note, we saw an earthquake here, a 2.7 at Narrows, Virginia, and a 2.8 at Massena, New York. Continuing on, there's been a volcanic uptick. Stromboli suddenly exploded with basically no warning. And that happened at about 15:19 local time. Volcanic tremors decreased, and then the explosion just suddenly occurred. Also, Etna produced another paroxysm. Following 5.5 days of quiet, the new southeast crater produced yet another paroxysm, one of the most powerful ones seen. It produced an ash plume over 27,000 feet in altitude. Basically, volcanic tremor increased in the morning. Strombolian activity restarted around 11:05 a.m. A lava flow started from the southern crater rim to travel southwest. At the summit vent, explosive activity increased gradually and merged into a lava fountaining by about 1 p.m. A 600 to 1,000 meter lava fountain was produced and a 9,000 meter volcanic ash cloud. Karimsky on the Kamchatka Peninsula also exploding. producing a flight level 090, or a 9,000-foot plume of volcanic ash. Subanosejima produced some strong explosive eruptions and a 10,000-foot ash plume. Luitolo exploded. Flight level 075, it's a 7,500-foot plume of ash. Sangay exploding. Flight level 210, a 21,000-foot plume of ash over Ecuador, near Sangay, near Revenador in the same country, a 14,000-foot ash plume there. As Revenador explodes as well. Sabancaya exploding in Peru, producing a 24,000-foot plume of volcanic ash. Nevado State Chilean exploding. Flight level 130, it's a 13-foot plume of volcanic ash. Please do not attempt to pole vault it, or any active volcanic calderae. In fact, pole vaulting calderae in general, even inactive ones, may be highly irresponsible. So tell your friends and foes, pick up some merch. You can find the links at smashomash.com, the source of this public service message. We've seen the X-ray flux here go into sort of almost like a background B range here. Not what you'd call flaring, just increased X-ray output here over the past about 12 hours. No major flares, but a few in the B range here. No spikes in the proton flux, no coronal mass ejections headed our way yet. There is a minor coronal mass ejection watch in effect. And here's the GOES magnetometer. We see some very weak readings here over the past about 6 hours. Very low readings here. And for you new viewers, the N's and M's represent noon and midnight local time for the GOES 16. So that's what those N's and M's mean. It does affect the readings. And let's look at some more magnetic data. Here's the top view of the plane field plot. Yesterday we talked about the crossing into the North Pole oriented current sheet shown here in green, and you can see now the Earth is showing up there on the graphics. By the way, this is from the National Sunspot Observatory. It's one of the more important pieces of solar data you could possibly look at. Here's another perspective of the same data. It shows you a great three-dimensional representation of heliospheric current sheet polarity, which is what these areas are. These are the heliospheric current sheet. As the sun is constantly blasting out protons, and they are polarized as per one of the solar poles. South pole shown in red, north pole shown in blue and green. And here's a line of sight coronal hole plot. You can see a north pole coronal hole rotating into the Earth-facing zone here. It's pretty diffuse. We'll show you a graphic on that in the next frame. This graphic also shows you the solar B field in blue. And here's some more graphics. You can see these coronal holes up here, sort of northeast of sunspot 2842. And sunspot 2843 showing up there. It looks like 2844 never got a name. Never even really got detected here. So pretty sure that one evaporated. KP index made it up to 4 for a brief period of geomagnetic unrest, and we still see slightly elevated geomagnetic conditions here, despite only seeing a KP of 2. Let's look at the real-time solar wind and see if that's responsible. Hint, it's not. So we saw a KP4 happening right around here. We did see an increase in the plasma temperature and a shift into the negative for the BZ here. You see this red line up top. The BZ made it all the way to -9 there, all the way to -11 actually. Quite a strong BZ there. A highly South Pole oriented magnetism for that series of moments. Also the solar wind density made it all the way up to 24 protons per cubic centimeter, even a little bit higher than that, a little over 30 there. And that was about the moment when we saw the geomagnetic unrest. It only lasted about 6 hours or so. Current conditions are solar wind density about 8.5, make it 9.5 protons per cubic centimeter. Solar wind speed about 400 kilometers per second. And here's 4 hours of data on magnetohydrodynamic pressure around the Earth geospace. So we see a slightly heightened magnetohydrodynamic pressure regime here, subsiding mainly to the magnetotail side, the non-sun facing side of the planet. And the conditions are calming down, it looks like here. That's the past 4 hours. Here are ground magnetic perturbations, and we'll actually show you the polar view as well, as we're seeing quite a few magnetic pulses around planet Earth right now. And like the last slide, this is 4 hours of data. Earth currently has 2 north geomagnetic poles, and the south geomagnetic pole is someplace in the Southern Ocean south of Australia, as opposed to on the Antarctic continent near the geographic South Pole. Here's 4 hours of data from the polar view, and we'll actually show you the aurora forecast next. We don't always show it, but when there's heightened geomagnetism, we try to show the likely areas of aurorae, as our viewers are probably interested in things like the aurora borealis and australis. Anyway, there's 4 hours of data from the poles of ground magnetic perturbations, geospace delta B. Here is the 30-minute aurora forecast. And this will probably subside in the second half. And indeed, you do see it subsiding here. Anyway, that should give you some idea of where the auroras are located, if there are any being produced. Now, we produce videos that go into 3 different locations. Our main locations for producing videos are youtube.com/smAshomash, twitch.tv/smAshomash, and bitshoot.com/smAshomash. We did do a live stream yesterday on YouTube. We regularly do YouTube live streams, and we regularly use Twitch, as Twitch is a fantastic live streaming platform. If you're viewing the content on YouTube, please don't forget to press like and subscribe. And don't forget to tell your friends and foes about the channel. We need you to help get our videos on screens, as the algorithms might just dislike us. Here's a teaser from yesterday's weekly Wednesday live stream. I don't know what I'll be talking about. I'm just going to turn up the volume and play a teaser. All right, and I won't put out any personal messages from me to governors. There you go. I hope that teased you. We did put it up as a community post, and you can find all of our videos at youtube.com/smAshomash/videos. Just in case they're not showing up in your subscription feed, I'm sure it's completely an accident. I'm sure it's totally not intentional. And again, there is exclusive content, more and more being created over at bitshoot.com, such as our recent 500 subscriber special, and thanks to our subscribers over there on BitChute. Don't forget to check all the other locations so you know when we put out content. Today's featured product is the Mansa shirt in purple. I'm wearing one now. And I'm apolitical. This is a completely nonpartisan shirt. And what it means is, make America not suck again. Since it's up to you and not the government to make America not suck, we've put out this product on our Teespring shop, one of our 2 Teespring shops. And if you head to smAshomash.com and click on the smAsho store, you will find a link to this shop. That is the link to this shop. And we want to know, are you safe yet? Are you safe thanks to masks and lockdowns and other non-pharmaceutical interventions? By the way, we're doing a cosmology segment today. It'll be separate from the daily space weather video. Make sure you check that out. Did you know that heliophysics is cosmology? Yeah, It's true. It's because the sun is the Rosetta Stone of all cosmology, folks. If we don't know how the sun works, how do we know how the galactic core of a galaxy 500 million light years away works? We don't, is the answer. We've got some minor charging hazards here as there are electrons surrounding Earth. Minor charging hazards here over the Western Caribbean, Mexico, Central America, and moving into the Central Pacific. All in the Northern Hemisphere, surface charging hazards are minor. Here's the 1-year chart from Solon.info of the electron flux. Very low levels of electron flux here following a bit of coronal hole wind. And it's been pretty much a dud here. We didn't get very high-speed components at all for the coronal hole wind, but it was enough to crater the electron flux. So there you can see those quite low levels of electron flux here over the past 3 days as a coronal hole wind stream comes in sort of sporadically. And here's the forecast model. NOAA forecasting flat levels of electron flux here. The green boxes are the forecast. The yellow diamonds are the observation. And here's a diagram of the Earth's Van Allen belts before we show you the total electron content forecast. So we showed some anomalies recently in this. Let's see if we continue to see anomalies, and indeed we do. Very chaotic electron flux here. That is probably the most extreme. That might be the most extreme we've ever covered on the channel. And it's very similar to this event that we saw, was it 2 days ago, I think? Look at the electrons flowing to the south polar region there. That is not the normal state of affairs, folks. And that's giving us insight into the Earth's magnetic field, as electrons are only about 1/1800th the mass of a proton. In other words, it takes about 1,800 electrons to equal the mass of a proton. So some major anomalies happening there between 1450 universal time and then finally subsiding here at about 1940. So about a 5-hour electron anomaly there over Antarctica, south of Africa, south of the Atlantic Ocean, and south of South America. Very similar to previous electron anomalies we've shown. That would make for massive GPS errors in those locations at a rather unexpected time. We'll let the whole video play through one more time here for the total electron content. So massive amount of electrons there showing up around the south polar region. And here's a diagram of the atmosphere. We show it daily to show you where the F layer is. It's located about 300 kilometers of altitude. It's the F ionosphere. And here's an animation of that. This is courtesy of the Australian Government Bureau of Meteorology. And we're seeing anomalies here over North America once again, as well as a large area of low vibrational frequency here. An F layer. When you see the red blobs, that's only an F layer. And we typically do see that at nighttime. But we're seeing very large areas of low-frequency ionosphere activity here, especially over the South Pole. We're also seeing high levels of ionospheric activity over the North American region. Right up here, you're going to see a sudden high vibrational area here. That's not exactly normal. And we look at the ionosphere daily to give us additional insight into the magnetic fields of the planet and, of course, the molecular behavior of the bridge between Earth and space. Anyway, we'll bring up the latest image there. It's the latest image there from 9:30 Universal Time. Looking quite anomalously there in the southern hemisphere. In fact, almost the entire south polar region, as well as a large portion of South America, only have a single layer, the F ionosphere, as opposed to the F2 or F3 or F14 layer. And if you only watch our daily space weather videos, make sure you check out our meteorology segments as well. We just recorded one. We streamed it live to Twitch, twitch.tv/smAsho. Here come bonus features for the daily space weather video. It's the latest hydrogen alpha imagery from El Teide, Spain. So a bunch of filaments up here. You can see some dark areas. Those are plasma filaments. Also some prominences over here and down here. Again, there is an active region rising. And here's our GOES 16 SUVI thematic map. And it looks like we've actually captured a coronal mass ejection here. You can see a little bit of material blasting off right around this area. And you can see that prominence down here in the lower left as well. It looks to me like a sunspot is rising, and we'll give you some of the earliest imagery of it. Let's press refresh. Here's the intensity gram. So here's sunspot 2843, looking weak, like it's degraded in the past 24. Here's 2842, degraded also in the past 24. And here's the latest colorized magnetogram. There's a magnetic field environment with 2843, again looking weak. Here's 2842. And this may turn into a sunspot. I don't know. It's got some weak looking umbra. And there you can see a little bit of the magnetic field coming through. We won't be able to see any umbrae yet associated with that active region. Come on, there we go. Anyway, there's the intensity gram, there's the magnetogram, and we'll close things out at 94 angstroms here. I believe the increased X-ray activity is actually coming out of this rising active region. It's certainly the brightest spot on the sun right now. It does not; those X-rays don't appear to be coming out of sunspot 2842 or 43. They're most assuredly coming out of this rising active region. So if I had to guess, I would think it's a sunspot. We'll zoom in a little bit on that for you there to close out the video. Thanks for tuning in to the Daily Space Weather. May that solar wind be at your back.